A 1.6 kilometer rock is passing Earth next month, and the headline number NASA released is designed to sound safe. 2.6 million kilometers. That is what they told you. What they did not tell you is what 2.6 million kilometers actually means for an object this size. The last rock in this size class that hit Earth ended the age of dinosaurs. The energy released was not measured in nuclear weapons. It was measured in mass extinction events. This is not a future threat. This is a scheduled pass. And the only reason we know it is coming is that in 1997 we happened to be looking in exactly the right direction at exactly the right moment. By the end of this video, you're going to understand exactly why 2.6 million kilometers qualifies as a near miss in planetary defense terms. You are going to understand what the designation potentially hazardous asteroid actually means. Not as reassurance, but as a technical warning about what happens to this rock's orbit over time. You're going to understand why the scientists tracking it do not look at June 27th and exhale. They look at every pass after June 27th and run the numbers again. And there is something else, something the mainstream coverage of this event has not touched. A fact about how this particular asteroid was discovered that changes every assumption about how many others like it we have simply never found. Stay with this, because the asteroid is not the story. The gap in our knowledge is the story. The asteroid is designated 152637. Scientists also call it 1997 NC1. It is classified by NASA's Jet Propulsion Laboratory as a potentially hazardous asteroid. That classification is not a description. It is a threshold. An object earns that designation when it is large enough and its orbit brings it close enough to Earth's orbit that it requires active, continuous monitoring. Large enough means capable of causing regional to global catastrophe. Close enough means its orbit crosses or approaches Earth's orbital path in a way that creates future collision scenarios worth calculating. 152637 clears both criteria with room to spare. The size estimate runs from 710 meters on the low end to 1.6 kilometers on the high end, nearly a mile wide. In asteroid impact physics, size is the variable that determines scale of consequence. An object 40 meters wide hits like a nuclear weapon. It destroys a city. An object 140 meters wide is the threshold NASA uses for global concern. It triggers continent-scale damage. An object in the kilometer range does not destroy regions. It alters the planet. The energy released on impact equals hundreds of thousands of nuclear weapons detonating simultaneously. The pressure wave alone would circle the Earth multiple times. The ejecta would block sunlight globally. The Chicxulub impactor, the rock that ended the Cretaceous period 66 million years ago, was estimated between 10 and 15 kilometers wide. 152637 is smaller. It would not trigger a mass extinction on that scale. But planetary scientists are not measuring this rock against Chicxulub. They are measuring it against the threshold for civilization-level disruption. And at 1.6 kilometers, it clears that threshold without question. Now you need to understand the distance, because 2.6 million kilometers sounds enormous until you put it in the right reference frame. The Moon is 384,000 kilometers from Earth. 152637 is passing at roughly 7 lunar distances, 7 times the distance to the Moon. In everyday terms, that is vast. In planetary defense terms, it is a near miss. The threshold NASA uses for close approach monitoring is 7.5 lunar distances. This asteroid comes inside that threshold. That threshold exists because within that range, the gravitational interaction between the asteroid and Earth becomes significant enough to alter the rock's trajectory measurably. Every pass inside that boundary changes the math for every future pass. Stay with me past the 4-minute mark, because what I am about to explain about orbital mechanics is the reason scientists are not relieved by June 27th. They are preparing for what June 27th sets up. 152637 is an Earth-crossing asteroid. Its orbit does not stay safely outside Earth's orbital path. It crosses it. Every single orbit. Most of the time it crosses when Earth is somewhere else. The geometry does not align. The paths cross, but the objects are not in the same place at the same time. That is what saves us on most passes. But orbital mechanics are not static. Every close approach, every gravitational tug from Jupiter, every interaction with Mars, every pass through the inner solar system slightly adjusts the trajectory. The orbit evolves. Scientists call these gravitational nudges perturbations. A perturbation that moves the asteroid's orbit by 1 kilometer today produces a position uncertainty of thousands of kilometers a century from now. This is why the potentially hazardous asteroid classification is not about the next pass. It is about the cumulative risk across hundreds of future passes over hundreds of years. We're not monitoring 152637 because June 27th is dangerous. We're monitoring it because each time it comes close, the model for its future trajectory gets updated, and occasionally those updates do not go in our favor. There's a number in planetary defense called the Palermo scale. It is a logarithmic measure of impact risk that accounts for both the probability of collision and the size of the impacting object. A score of 0 means the risk equals the general background rate for an object of that size. 152637 is currently tracked with no imminent collision risk, but it sits in the catalog that gets recalculated every time it passes, because the orbital uncertainty compounds. And a rock this size getting one calculation wrong is not a footnote. Here is the thing you need to hold on to. The asteroid that wiped out the dinosaurs did not arrive without warning in the geological record. It passed through a similar orbital corridor multiple times before its trajectory shifted into an Earth intercept path. We did not have telescopes then. We did not have the catalog. We did not know it was coming until it arrived. We have something now that the dinosaurs did not. But what we have is imperfect in ways that matter enormously. First, understand what this pass on June 27th actually does to the orbital model. Every close pass is a data point. The more precise the measurements taken during the pass, the tighter the orbital uncertainty becomes. Radar observations, optical tracking, Doppler ranging, all of it feeds into a model that gets recalculated after each event. June 27th is not just a near miss, it is an observation window. The data gathered this pass directly determines how confidently scientists can rule out future passes. Now for the piece that reframes everything else in this video, the discovery story. 152637 was discovered in 1997. Not because astronomers were systematically searching for it, because they happened to be pointing a telescope in that direction at that moment and it appeared in the frame. That is not a metaphor. That is the literal mechanism of its discovery. A chance observation during a survey that was not specifically designed to find it. NASA's current best estimate is that scientists have cataloged somewhere between 40 and 50% of all near-Earth asteroids larger than 1 kilometer. That sounds like progress. It means we have found roughly half of the mile-wide rocks. It also means roughly half of them remain completely unknown. No designation, no orbit model, no Palermo scale score, no warning system tracking their approach. For objects in the 140-meter class, large enough for global consequences, the estimate is worse. Scientists believe they have cataloged less than 40% of what exists in Earth-crossing orbits. For objects 40 meters and smaller, city destroyers, the catalog is essentially incomplete. Scientists estimate over 1 million such objects exist in near-Earth space. The number actually tracked is in the thousands. By the way, and this is the moment that rewards the people still watching, the 2013 Chelyabinsk event injured over 1,500 people in Russia when it exploded in the atmosphere. An object approximately 20 meters wide. It was completely unknown before it arrived. No warning, no catalog entry, no trajectory model. It appeared in the atmosphere at 60,000 kilometers per hour and detonated with 30 times the energy of the Hiroshima bomb before anyone knew it existed. 20 meters. Chelyabinsk was 20 meters. 152637 is potentially 1,600 meters. The catalog gap does not exist only at the small end. The reason we know about June 27th is that 152637 was discovered by chance nearly 3 decades ago. Its orbit has been refined across dozens of passes. The system worked for this one. The system has not worked for everyone, and the ones the system missed are not in any database. They are simply moving through the solar system on trajectories no instrument has ever measured. On March 9, 2023, an asteroid designated 2023 DZ2 passed Earth at 1.8 lunar distances. It was discovered only 9 days before its closest approach. 9 days, for an object roughly 40 to 70 meters wide, larger than the Chelyabinsk impactor. Discovered 9 days before it passed closer to Earth than most routine monitoring thresholds. That is not a worst-case scenario. That is a documented, cataloged, official near-miss that the planetary defense community uses to demonstrate exactly how incomplete the current detection architecture is. The system that caught the 2023 DZAO-2 9 days out caught it by luck. A different geometry, a slightly different approach angle, and it would have been detected on entry. Or not at all. NASA's NEO Surveyor mission, a space-based infrared telescope specifically designed to find the asteroids ground-based surveys are missing, is currently in development. It is designed to dramatically accelerate catalog completion for objects in the 140-meter class and above. As of 2025, it has not yet launched. The ground-based surveys doing the work in the meantime are finding new objects every week. But the catalog completion rate for the size class that includes 152637 is still below 50%. That is the number that matters. Not 2.6 million kilometers, not 1.6 kilometers. 50%. Roughly half of the rocks in this size class that cross Earth's orbit are still unknown. They are not hypothetical. They are real objects on real trajectories. The only difference between them and 152637 is that 1997 happened the way it did. Go back to what was promised at the beginning of this video. The distance, the designation, the discovery, and the gap. 2.6 million kilometers is not safe. It is inside the threshold that triggers active monitoring. It is close enough that the gravitational interaction during this pass will update the orbital model for every future pass. The potentially hazardous asteroid designation is not bureaucratic labeling. It is a declaration that this object's orbit, over time, has a non-trivial probability of evolving into an Earth intercept trajectory. That probability is currently low. It is not zero, and it gets recalculated every time this rock comes close. The discovery story closes the loop on why any of this matters. 1.52637 was found by chance in 1997. The system did not find it systematically. Luck put it in the catalog. And luck is not a planetary defense strategy. The ones we have not found are not waiting. They are moving. Their orbits are evolving. Some of them are on trajectories that will bring them closer than this on a future pass we cannot calculate because we do not know they exist. June 27th is not the threat. The open catalogs are the threat. The incomplete survey is the threat. The fact that the telescope specifically designed to close the catalog gap has not yet launched. That is the threat. The asteroid will pass. The instruments will measure. The orbital model will be updated. Scientists will confirm what they already believe, that this particular rock is not going to hit Earth in any trajectory they can currently calculate. And then they will go back to the catalog and keep looking for the ones they cannot yet calculate anything about. Because the ones they know are not the problem. The ones they do not know are the problem. Every close pass by a known object is a reminder of that. Not a reassurance, a reminder. Here is the sentence that closes every loop opened in this video. June 27th is not a near miss with a rock we found. It is a scheduled appointment with a rock we almost missed finding entirely. The gap between that almost and a rock we never found at all is not engineering. It is not funding. It is not political will, though all of those matter. The gap is luck. 1997, a telescope pointed in the right direction, an asteroid in the frame, a catalog entry made, 29 years of orbital refinement, a June 27th flyby we can watch and measure and learn from. That chain begins with luck. And planetary defense built on luck is not planetary defense. It is wishful thinking with better telescopes. The technology to close the catalog gap exists. NEO Surveyor exists on paper and in fabrication. The survey programs doing the work right now are real. The scientists running the models are among the best orbital mechanicians alive. What does not exist yet is the completed catalog. And until that catalog is complete, every close pass by a known object is shadowed by the unknown passes happening simultaneously. Rocks we have never seen on trajectories no model has ever calculated. 1.52637 passes on June 27th. The number to remember is not 2.6 million kilometers. The number to remember is 50%. That is the fraction of rocks this size we have found. The other half of the kilometer-class near-Earth asteroids are still out there, still moving, still unknown. If this changed the way you understand what planetary defense actually means, not as a science story, but as an infrastructure problem with a real and incomplete answer, share it. Subscribe if you want to understand the next close pass before the headline tells you it already happened.